Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/RudderStack. You shouldn't have to throw away the database to build with fast-changing data. You should be able to keep the familiarity of SQL and the proven architecture of cloud warehouses, but swap the decades-old batch computation model for an efficient incremental engine to get complex queries that are always up to date. With Materialize, you can. It's the only true SQL streaming database built from the ground up to meet the needs of modern data products. Whether it's real-time dashboarding and analytics, personalization and segmentation, or automation and alerting, Materialize gives you the ability to work with fresh, correct, and scalable results, all in a familiar SQL interface. Go to dataengineeringpodcast.com/materialize today to get 2 weeks free. Your host is Tobias Macey, and today I'm interviewing Eric Sammer about starting your stream processing journey with Decodable. So, Eric, first off, welcome back to the show. Good to have you on. And for folks who haven't listened to your previous appearance, can you give a bit of an introduction?
Sure. Thanks so much again for having me. So I'm the CEO and founder here at Decodable. We're a stream processing platform based on Apache Flink and Debezium for change data capture.
And do you remember how you first got started working in data?
I have to think. I have to go into the Wayback Machine on this. Yeah, so I think I very early got started working on database systems and data platforms and infrastructure. I've been doing this for 25, probably creeping up on 30 years. The place where it sort of really switched over for me was when I went from building internal systems at places like Experian and sort of various other organizations to working at when I joined Cloudera in late 2009, early 2010. So I was a pretty early employee there and worked on a bunch of what I would lovingly call the first generation big data stuff with Hadoop and and then eventually things like Spark and Kafka and things like that. And so that's probably where I really cut my teeth. Ever since then, 2010, I've been more focused on building platforms for other people as sort of a vendor. Is probably the only way to say it.
And so, bringing us to Decodable itself, we had you on, looks like in October of 2021, early in your journey. But for folks who aren't familiar with it, can you give a bit of an overview about what Decodable is, the story behind it, and why you decided that this is where you wanted to spend your time and energy?
Yeah, the last part of that is probably the funniest. I would rather never spend my time on this, but I hate this problem so much that I am determined to solve it or die trying. So I mean, decodable is it's a relatively sort of simple concept. I mean, there's a bunch of different sources of data. There's an increasing, especially on the destination side, an increasing number of destinations of data. And in our world, we think primarily on the source side about event streaming platforms like Kafka and Red Panda, Kinesis, GCP PubSub, things like that. Operational databases like Postgres, MySQL, Mongo, Oracle, SQL Server, those kinds of systems. And then on the destination side, analytic database systems. So all of the same systems on the destination side that I just mentioned on the source side, plus the analytic database systems, cloud data warehouse, data lake systems, Snowflake, Databricks, even things like S3 with like Parquet data and those kinds of things. And increasingly this like long tail, more specialized data infrastructure. And we would include like the real-time OLAP systems like StarTree and Imply or Apache Druid, Apache Pinot, those kinds of systems, Rockset, so on and so forth, as well as things like Elastic and full text search systems, InfluxDB, sort of like telemetry, like metric stores and those kinds of things. And so Decodable really exists to sort of sit in between those source and destination systems, including microservices that are hanging off of Kafka topics, and be able to process data in real time, filter, join, enrich, aggregate, sort of all the verbs that people would use either in SQL or through Java APIs. And so the open source projects that we're based on, again, primarily Apache Flink on the stream processing side, Debezium on the change data capture side. So we're built on top of those two systems, and so that's the set of APIs and capabilities that we're exposing through the commercial product, that is Decodable. The genesis of the company is also probably not sort of surprising. It's just that, like, as the source systems grow and get more complex, as the destination systems grow and get more complex, and the processing in between them, and especially the fact that the data is driving coming from operational systems and driving other operational systems, including microservices, including caches like Redis, full text search systems, but also the analytical database systems, Snowflake, Databricks, so on and so forth. I think that the tooling that sits between them has historically been super powerful, really robust, but quite frankly, really hard to use and reason about. Whether it's how do I reprocess data, how do I make schema migration, how do I make schema changes, what's the right way to think about data quality and observability, what's the right way to build and deploy those pipelines as part of applications and CI/CD processes. And so, we really wanted to solve this problem and make it relatively simple, or simple as possible, to be able to process the data, to add new source and destination systems. That's a long explanation, but like fundamentally, like, that's the space in which we play. And like I said, I think that this problem is just far more complicated than it should be. And I will die trying, to drain the complexity out of this problem. It's just, it doesn't need to be as complex as it is.
And to that point of complexity, streaming systems started to become in vogue, I want to say maybe creeping up on 10 years ago now, as a lot of the so-called hyperscalers were getting to that point of hyperscale where they said, oh, we need to be able to start processing all of this data in real time because all of our batch jobs are taking a week to complete. So Twitter was one of the early ones with I don't remember if they were the ones for Storm or Samza, but I remember like hearing about Storm, Samza. Flink was a little bit later on, Spark streaming. There were dozens of streaming systems. Now it seems like it's coalesced mostly down to a handful of two or three. Within the overall space of complexity in streaming, you hear a lot about things like checkpointing, windowing, at least one's consistency, exactly one's semantics, challenges of the kind of late arriving data. I'm wondering, given the fact that we've been dealing with these problems for the better part of a decade now, how many of them are still something that somebody coming into the space really needs to understand still? How much of it are you still dealing with building Decodable, and how much of it has been solved through just kind of force of will or new updates and understanding to how we can address these systems in a more sane fashion?
I mean, that's the spiciest of spicy questions, because I mean, that's the complexity I think that we're talking about, all the things that you mentioned. So I think that that's right on the money. And I'll be really honest with you. I think that we've handled some of those things. So there's quite a bit of configurability in these systems. And in fact, you're talking to Robert Metzger, is the PMC chair of Flink. He's one of our engineers, and he and I were talking about this problem. And he's like, you got to understand that, like, Flink was built in a way that allows quite a bit of tuning where you know a lot about the workload. And if you compare that to something like Postgres, where like you just fire queries at these things, and like, yes, there's tuning, quite a bit of tuning you can do on Postgres, but for the most part, it just kind of does what you expect it to do. So I think that's the right question. So a lot of what we do is trying to solve exactly those issues. So some of them, things like checkpointing and memory tuning and buffers, and in sort of configuring at least ones versus exactly ones, and getting the semantics right, and the retention and the timeouts, those kinds of things, I think that we've actually done a pretty good job here at Decodable. And I think it is possible to paper over a lot of that complexity. Some of the challenges around late arriving data and state management in terms of like replay, and like what happens if you have bad data, and like how do you sort of compensate for that, those things I think are intrinsic to data engineering. They're not even strictly stream processing problems, although they do tend to rear themselves in stream processing in ways that you probably don't encounter as much in batch. So I think that there's definitely some of that. And there, it's not so much about making that problem go away, because like I said, I think it is like an intrinsic thing that you have to think about, but I think you can build workflows and processes and systems around that to at least guide people down the path of making sane decisions, right? So like if you care about late arriving data, like there's actually a way of presenting the concept of like watermarks and like all of this deep complexity to somebody in a way that like is more intuitive, I think might come out of the box with some of these projects. And again, not for lack of trying, these things are incredibly sophisticated and complicated and have to handle this like bevy of use cases that vary in their needs with respect to timing and all and state and later having data and all these other kinds of things. So I think that we've actually come quite a long way, especially in the Flink ecosystem, where I think things are starting to really coalesce just in the last couple of years. I mean, Flink has been around since, as a research project, I think it was like 2010. I think at 2014 it actually became the open source project, Apache Flink, from the research project. But like Sam's out of LinkedIn and Storm, which I think primarily came out of Twitter. There's been so many systems that I think have carved a wonderful path here. But I really think that the industry is coalescing around Flink as being sort of the de facto winner. Maybe the way that Kafka has. I don't know that I'm allowed to say that out loud, but like maybe there's a parallel there.
With all of that complexity, with all of the different systems that are and were necessary to be able to even think about addressing these streaming use cases, that raised the barrier to entry quite substantially, so that most people said, oh, streaming would be great. And then they started to dig into the problem and said, oh, heck no, I'm not going to deal with that. I'll just deal with maybe smaller batch sizes and figure it out. And now that we do have platforms like Decodable and many others focusing on different aspects of this streaming ecosystem, how does that influence the types of problems, the types of businesses that are actually starting to implement streaming data as a core capability of their business?
It's a great question. I think we certainly are seeing it objectively more and more. There are companies, just even a couple of years ago who said like, we don't have a streaming use case, that have like come around to the idea, like logistics, for instance. Like the joke I always make with the team is like, nobody really thought that they needed to know exactly where their pizza or Chinese food was until like Grubhub and DoorDash and like all these other companies started like showing you the little dot on your mobile device. And now customers just expect that. So I think the use cases have really pushed a bunch of people into thinking about these things, especially in retail, fintech, logistics, inclusive of like these delivery services and those kinds of things. In gaming, systems like Fortnite or companies like Epic Games and stuff like that have done quite a bit with real time processing based on things like Flink. I think the first step for a lot of people was adopting an event streaming system like Kafka, right? And I think that like when you look at like the Fortune 500 or even like the Global 5,000 or however you want to slice the market, I think like most people have done that. Well, maybe that's an exaggeration, but like most of the Fortune 500 have done that for sure. Obviously companies like Confluent and AWS have really popularized the notion of event streaming in general. And then like we look at that the way I think people look at like S3, right? Like that's the primitive that enables a whole bunch of other things to follow. And I think stream processing is the natural thing that follows that. First I move the data, then I'm able to process that data without actually having to write microservices that listen or produce directly to those Kafka topics. So it's a natural extension. And I think that we're sort of at that phase now where people have like figured out event streaming in general. And now they're like, oh yeah, this handles ingest into analytical database systems. This handles connectivity between microservices. And like now they're starting to get to like, okay, but like it doesn't connect to everything I need it to connect to, or it doesn't handle change data capture versus append only streams. And a lot of the things that need to talk to each other don't speak the same language in terms of like the payload or the semantics, or there's governance and compliance stuff. Like that service isn't allowed to have PII data, but this one produces it, but they still need to talk. So like, how do you deal with that? Well, the answer is stream processing. Like that's where that fits. So use cases like that, I think, have pushed people into it. And so, I think it's it's a little bit of a renaissance, like a second renaissance. We just came out of Confluent Current last week, or a week and a half ago. There's like 2,500 people, and it's like all the stalwarts. It's every company you could ever imagine, in that Fortune 500 space, and some of the sort of higher end of what we think of as like the more sophisticated mid market. I don't think we're there yet, in the sense of like it's nowhere near as robust a market or a technology stack as like the data warehouse. People go like, okay, like it's either Snowflake or it's Teradata or it's BigQuery or something like that. I don't think stream processing is quite there yet, but I think it's on its way to that. And we're very lucky to have been, I feel like we built Decodable like exactly the right time, where we're sort of cloud only, and like we're able to really take advantage of, kind of where people are at and meeting them where they are.
And an interesting thread to pull on as well is you have appropriately used the right semantic terms for separating these two concepts of streaming that will often get muddled with people who are less aware of the space of event streaming and stream processing. And I'm wondering if we can maybe clearly draw the line between those two, because particularly with things like Kafka or with Pulsar, where they have some measure of transformation available, or Red Panda in particular with their inline WASM modules being able to do some measure of transformation on events as they get entered into a topic or moved between topics, as opposed to what you would do with a Flink. Wondering if we can maybe kind of make that line a little bit brighter for people who are confused.
Yeah, I mean, I think you're absolutely right. So when we say event streaming, and I understand the language is confusing on this, I kind of wish that there were less, that these two phrases had fewer words in common, right? But when we say event streaming, what we really mean is the durable storage and movement of data in real time. And so some of these projects, like you mentioned, like Red Panda with its WASM support, or Pulsar with its Pulsar functions, have different capabilities that are sort of either squished together in one box, and some, in certain cases, they are sort of effectively two different boxes. So I think that further makes things mushy for people. So we think about it as storage and durable storage and movement of data. And then we think about the processing and connectivity of that data. And connectivity, of course, being like connect to my source systems, connect to my destination systems, kind of get it onto and off of like a Kafka topic or something like that. So like using the Kafka ecosystem as an example, storage and movement is the Kafka broker. The connectivity would be Kafka Connect. And then the processing, that's where it starts to get a little bit sort of interesting. There's K streams, there's KSQLDB, there's obviously Flink. Our, weapon of choice in this at Decodable is Apache Flink. And there's other systems that you can sort of pair with that. And so that's the way we think about it. And I don't know that these are proper nouns: event streaming, event processing, or stream processing. Some people, like you said, sort of abbreviate that as saying like Kafka, and like to them that means everything. To me, that means the broker, right? So like, there's certainly some squishiness in there, but I think that that's the right way to think about it, because there are cases where like we love Kafka the broker, we really do. In terms of connectivity, I think that, quite frankly, like I'll say the quiet part out loud. Like, I think that the way we do connectivity, which is actually based on Apache Flink, has advantages over doing that with Kafka Connect. I think that processing Flink has advantages over K streams. I know there are friends of mine who will throw rocks at me for saying that. We're sort of diehard K streams people, which I appreciate. We could debate that all day, but I actually think that there are cases where it makes sense to think about those things as individual blocks that you can sort of stitch together.
This episode is brought to you by Datafold, a testing automation platform for data engineers that finds data quality issues before the code and data are deployed to production. Datafold leverages data diffing to compare production and development environments and column-level lineage to show you the exact impact of every code change on data, metrics, and BI tools, keeping your team productive and stakeholders happy. Datafold integrates with dbt, the modern data stack, and seamlessly plugs in your data CI for team-wide and automated testing. If you are migrating to a modern data stack, Datafold can also help you automate data and code validation to speed up the migration. Learn more about Datafold by visiting dataengineeringpodcast.com/datafold today. And in the product journey that you have taken at Decodable since we last spoke in October of 2021, I'm wondering how the adoption curve has influenced your thinking around your product focus of how to reduce the level of upfront complexity that people need to address to start using these technologies and experimenting with these techniques, and some of the ways that the overall industry trends have also factored into the ways that you think about the solution space that you're targeting.
Yeah, absolutely. I mean, so there's a couple of things here that I think have been, just things we've learned. And like, I don't know, maybe somebody would tell me I shouldn't do this, but I'm going to tell you all the stuff that we got wrong, and that we've like since fixed since 2010, not just like in our product, but like in our understanding of the space. So like, in 2010, just for context, Decodable was about 8 months old. We had just raised our Series A. We're now 2.5 years in and have spent quite a bit of additional time with customers and things like that. So a couple of things. One, I think initially we thought that this space, stream processing space in general, was at the point where it was really going probably more mainstream than it really was. Like we thought it was further along. And so we kind of went like, well, obviously the right thing to do is to focus on SQL because everybody knows it. And like, that was the right way to think about it. And I think we were correct, but incomplete. So like one of the things that I think we've learned since then is that when we talk to customers, this is about 80%, 70%, 90% of workloads that can be expressed in SQL. Because like a lot of what people do with stream processing is like, I just need to like route this stuff, or I need to knock out some PII data, or I need to filter records for just the successful HTTP events, like whatever is like really simple stuff that is like a one-line SQL statement that like effectively replaces like a whole like chunk of ream of like Java code and like all these other kinds of things. It's one less service to explicitly like build an instrument and monitor. Like you can sort of push that to a vendor, and like that has sort of advantages. And then there's like this 10-20% of use cases that are just different. And they're different because a few reasons. One, purely from an expressiveness perspective, SQL is just hard. And that's typically because there's like more sophisticated state management, really, really complex sessionization use cases, or data enrichment use cases, for instance, can sometimes require very specific kinds of like time management and window functions and state management. There are cases where people have to reach into third-party libraries, and I think especially as like LLMs and AI and like things that are above my pay grade are sort of like all the rage. I think those kinds of things, like there aren't SQL functions, or they're difficult to express in SQL for various reasons, or they have deeply, deeply, deeply nested data that is complex to think about in the relational model for a variety of reasons. Some of those things could probably be SQL, but it's more natural for people to think about it as imperative code. And so people just like were like, we have to write code. So we had to wind up exposing full support for the Flink APIs. And that allowed at least 50% of the people that we were talking to who said, we love what you're doing, but we can't use you because you're SQL only, to be able to use us. And like maybe that's internal secret sauce at Decodable, but like that was like a major thing that like in retrospect you're like, yeah, of course, but the market just wasn't so far along that like everything was SQL. And so like I truly believe that you do need both. Flink has of course recognized this from very early on. We wound up exposing that functionality and sort of building support around that in a way we think is sort of super nice to use. But that was one big thing. The other big trend is this issue of, especially as more of the older or highly regulated businesses or just more complex businesses move to cloud with their data platforms, not just like their application stack, but their data platforms. I think this question of like, can I actually ship all of my event data to a third party vendor to be processed and then have it returned to me? Some companies, banks, insurance companies, healthcare providers just like sort of like recoil when you're like, yeah, just like give us all your data, unless you're like a Snowflake, unless you like a Salesforce or somebody like that. But like, let's be honest, Decodable is not Snowflake at this stage, right? And so like the level of trust we enjoy with customers is probably not as robust as like a Snowflake or somebody like that. And so I think that customers rightfully want to be able to maintain control of their data. And so our answer to this, and Red Panda has done something similar, and a couple of other vendors in the space have done something similar, is this like bring your own cloud model, where we cut the platform into a control plane and a data plane, and the control plane is only control, command and control messages, and the data plane is the part that actually processes data and touch customer infrastructure, and the data plane runs inside the customer's cloud account. So it's still cloud. It still has a lot of the features of a managed offering because we're able to collaborate on like the management of that, but it is resident within the customer's account. And so like they have full control over the data that happens there. And I think that I don't know whether there's some debate raging online right now about like whether or not that's like the future of cloud services. I'm more pragmatic. So we offer both, fully managed and bring your own cloud, because we have customers that ask us for both, quite frankly. Some people prefer one over the other. And I think that that was an interesting thing that we've learned. I think data infrastructure in the cloud in particular has a high wall to climb until you are as mature and well developed as a Snowflake. Sorry, that's a super long answer. Hopefully that makes sense.
No, that makes perfect sense. That's great. I love the detail. And as to the types of problems that people are trying to solve when they come to Decodable, you mentioned that you targeted SQL. You said, this will be great. Everybody knows SQL. This will solve everybody's problems. Oh, shoot, they actually want to program. And I'm curious what the process looked like from that realization to the point where you said, okay, here you go. I've given you what you want. And some of the minefields that you had to traverse on that journey.
So, I mean, the issue in that particular instance is not so much like how do we support it, because, like I said, we're sort of building on the shoulder of giants here, standing on the shoulders of giants with Flink. So, like, Flink already has the super robust data stream API and table API that are different levels of abstraction that are quite frankly like really ergonomic and nice to use for most use cases, or for all use cases. I'm hedging a little bit because there's going to be somebody who's like, well, I hate it. Okay, fine. But I think that Flink already has a lot of this capability. The issue for us was like, how do we offer it in a way that is safe? And because like the real issue for a cloud provider is that like that is untrusted third party code, right? You basically have customers uploading like arbitrary code to a cloud service and saying, run this for me. And for us to build a service around this, and we've even talked to people internally building data platforms who are like, the users could, I might trust it to not do sort of adversarial things, but we do worry about supply chain attacks. We do worry about like exfiltration of sensitive information, or more often we worry about that data, that code just like chewing up arbitrary resources in a way that like impacts like other workloads inside of like the bank or the retail or whatever it might be. So I think resource management, and then like security and safety and resource isolation is the biggest challenge there. And so we spent so much time trying to find the safe, correct, performant, isolated, but still cost efficient way to do that, and wound up having to thread a pretty rough needle on that. We think that we've actually done the right thing in that, like, foremost is security and safety. And so like we spent a lot of time and effort basically trying to figure out how to do that inside of Decodable. I'll just say that, like, I won't go into a ton of detail. I'll just say that, like, if you upload an existing Apache Flink job to Decodable, it effectively gets isolated hardware on an isolated sub segment of a network, right? And all of that infrastructure is dynamic. And we had to work pretty hard to find the reasonably efficient and cost effective way for us to do that. In the BYOC model, it's a little bit easier because that's actually the part that's running on the customer's infrastructure. And so like it's easy for them to have like isolated infrastructure because it's single tenant by definition. But basically user code inside of the fully managed version of Decodable is also single tenant for that job. And so there's quite a bit of infrastructure that goes into that. And then the resource isolation from an efficiency perspective, like if you're doing it from a security standpoint, you're kind of like also doing it from an isolation, like a workload isolation perspective. But that was like the biggest nut for us to crack by far. And then there's like secondary stuff, which is like, what if people touch parts of Flink that we sort of have to control and manage for a variety of reasons, for like observability, infrastructure, and those kinds of things. Those are secondary and probably easier to solve. They're quite a bit of work, but like conceptually easier to solve. But man, that user provided code thing is just, it's rough to get right. But once you get it right, it is so exciting, because like the UX on it is basically the same as the SQL UX. Like you upload a chunk of SQL, you upload a jar file that's built against the open source APIs, and like magic happens, right? Like it just works. And like that has actually been really nice to watch customers be able to take pre-existing stuff, and without making like any code changes, without even recompiling, just kind of go like run this, and it sort of gets all of the managed goodness, that sort of comes from that. But man, is it a lot of work.
Well, I mean, at least they actually have the deliverable of a jar file that you can plug in. Imagine if it was PHP or Python.
Oh my goodness. I mean, so I think there, this is a place I think of more deep research on our part. We talk a lot about expanding the language support. So like Java, like Flink is, for better and worse, is Java. It enjoys a rich ecosystem of tooling and compatibility, and the runtime performance is arguably better than it should be. I'll be honest with you. Modern Java is like incredible. Sure, somebody's like, well, I could hand code it in Rust better. Yeah. I agree. I'm a C++ Rust person myself, but like, yes, but sort of like strikes the right balance. But like opening Flink and those capabilities to languages like Python, Go, JavaScript, TypeScript is actually really, maybe even PHP. Who knows, Tobias? Anything is possible. But I mean, but I think those kinds of things are actually really important, because certainly for data platforms at larger organizations, you're typically not homogenous in language, right? It's polyglot programming is like a whole thing these days, and so I think that being able to support that is something that we know we need to improve, not just within Decodable, but the larger, I think, Flink ecosystem. And I think other people in that community probably would agree with that. PyFlink support is okay. It needs to be better. It really does.
To that point of the experience for people who are working with Decodable, you mentioned upload some SQL or upload a jar. I'm just wondering if you can talk through the overall surface area of developer experience and the onboarding process, the concepts people need to be aware of and factor into their work as they're using Decodable, and some of the challenges that you've had as far as how to improve the overall experience and reduce points of friction in their journey.
Yeah, I think this is, again, one of those areas where I don't think the work is ever done. Systems like Postgres have like existed forever. And so the UX on that, or the DX on that, is the developer experience is relatively sophisticated, and well known. There's patterns around it. And I think stream processing, because it is effectively an integration technology. It's all about connecting to sort of upstream systems, downstream systems, and it has the overhead of effectively being like a query engine, like it's not a database per se, but like it has all the hallmarks of the query engine portion of a database system, arbitrary workload definition, those kinds of things. There's quite a bit of sophistication and complexity in that. So inside of Decodable, we've tried to distill this down to like as few concepts for somebody to learn as possible. So we think about the world in terms of connections to things, streams that are produced or consumed by connections, and then what we call pipelines, for lack of a better word, that actually process data in between those streams. And then sort of like that allows us to then compose those three core primitives into effectively sequences or DAGs of like this connection goes to this stream, which feeds these five pipelines, which feed maybe these other pipelines, which feed these other connections, and so on and so forth, and give people the ability to effectively design the end-to-end data flow from arbitrary source systems to destinations. But there's like issues of discoverability and impact analysis. If I change this connection, what does it mess with downstream. I have malformed data that's like stuck in this one part of the DAG. Like, what is the implication of that? Helping people to like navigate that and to discover, diagnose, trace, whatever the verb is, I think is always laden with a certain amount of friction, because you sometimes want to think about the end-to-end data flow and infrastructure through different lenses. One is like, what processing supports this microservice, or this, like, flows into this snowflake table. There's, how is this data used, which is more of like a source side concern. There is the dependency analysis portion of this that is so difficult. So we've actually tried to create this, like, for every object, what's upstream of it, what's downstream of it, and like basically lineage information to be able to walk the graph as you sort of go through this, and then given people tooling, command line, API, UI, DBT. So there's like lots of different interfaces to this to be able to operate on different resources within that graph. And so, like, if you're a SQL person and you're thinking about using Decodable to get data from like Postgres to Snowflake with a bunch of transformation in the middle to like cleanse it or to like better structure it to flow into Snowflake, so that you're not sort of burning warehouse credit, to be able to do things, you're probably thinking in like a DBT and SQL mode. And in that case, you want to be able to fit into the existing workflow of DBT. You don't want to rip somebody out of that and try and teach them a different way of working. So thinking about it from the perspective of like jobs to be done and sort of like the tooling that different personas, like, which are really different flavors of the same persona. They're like roughly someone operating in like a data engineering or application, like back-end developer type role, but they might be like coming at it from the lens of data warehousing or microservice development. Like, like there's like different dimensions on that. And I think as much as we can fit to someone's existing workflow, that's our goal. So like, we have to offer APIs for absolutely everything. We have to offer command line tools to like script CI/CD, stuff, that happens in GitHub Actions and all, Harness and like all these other kinds of systems. We have to provide DBT tooling for the data warehousing flavor of data engineer. We have to provide a UI to allow people to very quickly sort of navigate and understand the way that they would like an AWS console, right? Like, and like, let's be honest, there's probably people who do more inside of those UIs than that are like, I know I should be doing this in Terraform, but like I'm not, and like, someone's going to catch me. But I think it is the right environment to be able to like develop and experiment and try things, and then you kind of go back, codify it once you know that it works. And so I think we still have tons of work to do on this, but I think we're starting, like we're down a path where a lot of people are able to be pretty productive in short order, but lots of work left to do there for sure.
As more people start using AI for projects, two things are clear. It's a rapidly advancing field, and it's tough to navigate. How can you get the best results for your use case? Instead of being subjected to a bunch of buzzword bingo, hear directly from pioneers in the developer and data science space on how they use graph tech to build AI-powered apps. Attend the Dev and ML Talks at Nodes 2023, a free online conference on October 26th featuring some of the brightest minds in tech. Check out the agenda and register today at neo4j.com/nodes. That's NEO, the number 4, j.com/NODES. And to the point of the APIs integrating with people's existing workflows, that also brings, and also the much maligned ClickOps approach of just do it in the UI. That also brings up the question of the control surfaces of where do you want people to be thinking about how to interact with Decodable. Should it be fully managed via their data orchestration system? Does Decodable want to own the whole interaction? Should Decodable be something that people don't even know exists and it just plugs away and does its thing? I'm just curious how the thinking around that also influences the ways that you think about how to present Decodable and the types of control capabilities that you want native to the platform versus just exposing those capabilities to the other orchestration systems that people want to bring to bear?
I think it's a really good question. And this is a place I think where streaming is a little bit different from the batch side. So like when we don't necessarily think in terms of orchestration because these things, although I suppose there's life cycle, right? Like you start a connection, you start a pipeline that runs forever until you have to like update it, or something like that with like new version of the code or something. But I mean, so the orchestration doesn't look like an airflow. The control surface, to your point, doesn't look like an airflow. It looks a whole lot more like a code deploy. So like we have customers today who are like, we think about this as being something we do through Terraform, and like that's the way in which they manage or want to manage connections and pipelines and those kinds of things. We also have customers who think about this as like, I'll be honest with you, like I think it's part of like scripting as part of like inside of a make file. Like I know at least a couple of customers that run like make pipelines, and like what it actually does is call our CLI tool to like go like sort of provision a bunch of things. And then somewhere I shouldn't rat people out. There's definitely a click ops demographic. You know what I mean? Like I think there are people who are like, look, man, like sure, I should do all that, but like, what if I just run decodable create stream, decodable create connection, from the command line, or I go into the pipe into the UI and I like plug in my Kafka parameters and click start, and like there are people who do it. And then typically they do go back and like they figure out how to do it. And then there are people who have intensely sophisticated internal infrastructure that is part of their own sort of deployment and development processes, and they just directly touch REST APIs. They really do. And so for some people, their developers are using Decodable and they don't even know. So like they have this, I define some SQL and some connection information inside of a YAML file, and then like that gets committed to like Git or GitHub, and something wakes up and takes that YAML file, parses it, and then makes a bunch of API calls to Decodable, and which is plus minus what our CLIs do, give or take. But I think that the important thing for us is that it almost doesn't. I mean, we have an opinion about sort of like what we think is like acceptable ways to run the stuff in production. But I mean, like, I don't know if you've ever tried to tell a bank how they should do code deploys, but like, let me tell you, like, it is a losing proposition. I think as vendors, like, we should have a vision, we should have a way of thinking about things. So like, if you don't have an opinion, we'll tell you like, well, here's like a good way to do it. But I mean, you have to fit the internal platforms that people have built on top of you within a bank, an insurance company, a retailer. Otherwise, you don't get to sell to them, right? You just don't. If you're like, well, you have to do it this way. Your opinion does not matter, And I think that to me is developer centricity and empathy, is like making sure like, well, how do you guys want to see this, like, and if you have no opinion, then like here's three things we see customers do, you can pick one. But I think we constantly get feedback around that. I would say that most people use some portion of the UI during the development process, some portion of the CLI for deployment and things like that. And then maybe they use it directly, or maybe they build tooling on top of it, but like it's approximately like that. And then, like I said, DBT is kind of like a special workflow. And, Terraform is probably a special workflow, but those things are like approximately built. They are built on top of our APIs, right? So like, that's not like really that special, but like it's a workflow, it's a lifestyle. It's not just a technology, it's a lifestyle.
Yeah, it's funny how they grow to be that way. And another element that we haven't dug into yet, but that keeps popping up throughout, is these connections where you have the source systems you're pulling data from, you have the destination systems you're pushing data into. And earlier on, that was, I have a lot of source systems, I have one destination system. So all of the complexity goes into the destination system, and I just make all the source systems look mostly the same. That's the approach of things like Airbyte, Singer, etc. Now that set of destination systems keeps growing, and then the idea of reverse ETL just ballooned it even further. And I'm wondering how you're thinking about how to make that a manageable problem without having to just spend all of your engineering time on writing connectors for all the different source and destination systems, and then the whole rest of the system just stagnates.
Yeah, no, I think anytime there's connectors, prior to starting Decodable, I was at Splunk, and Splunk has like this incredible long tail of connectors for sort of various systems. And so I think anytime you're building connectors, you have to be careful of the long tail problem. So I think that like we look for points of leverage in this, and we think customers should look for points of leverage in this. There are natural aggregators, and what I mean by that are sort of places where things natively integrate and get sort of first class support. And I think that there are two, maybe three natural points of gravity in the data platform: the operational database, the event streaming layer, and the data warehouse, right? Those are your three natural aggregators. There are an increasing number of systems, obviously, that support systems like Snowflake and things like that. There's obviously a bunch of things that directly support systems like Postgres, MySQL, Mongo, Cassandra, whatever your flavor is. And there are increasingly a bunch of things that support Kafka or Kafka, Pulsar, Kinesis, whatever, as natural aggregation points. Like as an example, getting like the equivalent of NetFlow data out of something like AWS, you can get that on a Kinesis stream, right? And like or like security audit logs, you can naturally get like in a in a Kinesis stream. And so like we think that those things are sort of natural aggregators. I should also include object stores, S3 and GCS and those kinds of things. And so I think to whatever degree we can, we spend most of our time thinking about the natural aggregators and then how to get data in and out of those natural aggregators. I think, and then some of those are natural source systems and natural destination systems, and then some of them are natural source and sync systems. So I think the reverse ETL thing, like, listen, I don't think that the data warehouse is the right source to drive operational systems. I will die on this hill. It doesn't have typically that team is not on call. They don't have the same uptime SLAs. You don't think about feeding microservices from your data warehouse. Just doesn't make a ton of sense to me. Now, I think that there are vendors who will always try and consolidate in those places, but they're not going to meet the SLAs on like latency. They're not going to meet the SLAs on like a bunch of these other things. Uptime, maybe. I won't speculate on that. So I think that a lot of the things that are done through reverse ETL should almost certainly be driven from the event streaming layer. And so like I think that if you're getting operational events from Postgres databases or Kafka, that should not pass through the data warehouse to on its way to a HubSpot or a Salesforce. I think it can also go to the data warehouse, right? So I think the event streaming layer and the stream processing layer is the point where you actually do distribution of this data to terminal systems, of which I think the data warehouse is mostly a terminal system. There are exceptions that there's like model training and those kinds of things that happen there. But I think that pushing like this increased, well, like let's sync faster to and from the data warehouse, or at least from the data warehouse. I think to the data warehouse probably makes sense, but like from the data warehouse, I think is a losing battle. I think it isn't cost efficient, and I don't think that it flies. So I think that, I mean, this is a horrible answer to your question, but like I'm down this path and I'm not letting go of the bone. So I think that like the stream processing layer I think is really the right place to do this collection, cleanse, and distribution. And then there can be further refinement of data inside of the data warehouse. I think that makes sense. Uh, I like I said, I think I did a poor job of answering your question, but that's sort of like where my brain goes when I hear that.
No, I think that that's a great point, and I appreciate your opinions on this matter. Where people hear something, it mostly makes sense, but they don't take the time to evaluate it in detail, and so that's how things grow, that's how somebody says, oh, of course reverse ETL comes from the data warehouse, because where else would it come from? So I think that that's definitely a useful insight for people, and lots of interesting things to dig into. On that point of the streaming system should be what's responsible for pushing to reverse ETL destinations, HubSpot, MailChimp, Salesforce, what have you. The converse to that is, well, it needs to go through the data warehouse because that's where all my other data lives, and that's how I enrich those records. And to which I assume the response is, well, then you just use the data warehouse for the enrichment, but you pull that through the streaming system to inline that data into the event as it comes from Postgres on its way to whatever its eventual destination is. I'm wondering if you can give a bit more color to that.
Yeah, I mean, so this is where I think it gets interesting. I think that the question then becomes like, well, you could do the enrichment in the data warehouse, but if the streaming layer is the thing that actually collects data from all of the operational systems and is feeding the data warehouse, it is also capable of performing the enrichment, to go to those other systems. So I think that it is very much unlikely that there is one place, I think, that fits the uptime, the SLAs, the latency requirements, the throughput requirements of all these things. So I don't think it's actually a bad thing to have to be able to do enrichment with like operational information from a Postgres in the streaming layer, and also to have that same data inside of the data warehouse, right? So like a lot of our customers will use Decodable or something like it, if you don't use Decodable, to collect data from all these operational systems. They put effectively the raw data, or mostly raw data, slightly massaged into the data warehouse. Batch workloads inside of the data warehouse can of course use that data directly, but when they are feeding systems like online operational systems like transactional messaging with like a MailChimp or SendGrid or something like that, they may be also doing that enrichment in the streaming engine. And this is why we support things like joins and all of this kind of sophisticated processing, stateful processing inside of the stream processing layer, is so that you can do that enrichment at the streaming layer and then directly feed the operational system, effectively bypassing the data warehouse for that use case. So I don't think that people need to be thinking about this as like either or. And I'll be honest with you, people go like, well, what about data duplication and what about logic duplication? And our point is like, well, that's why we support SQL. So the same SQL that you can run in the data warehouse, you can also run in the stream processing layer. That's why that is important. That's why we also support things like DBT, so that you can actually push that processing upstream when you need to, not all the time, but when you need to, in order to be able to fulfill that. And the upside of that is that you get this decreased latency, better cost efficiency, you know, richer data that may be coming from sort of even more systems, at scale in the hot path. And then you can feed the microservices, you can feed SendGrid or MailChimp, you can feed, all of these other systems in parallel. And we've tried to make that as painless as possible. But I think people like engineers in particular, myself included, will sometimes over rotate on, well, you're sort of repeating yourself and these kinds of things. But I think for online operational infrastructure, which is what that is, transactional messaging or updating records in Salesforce, like having your sales team have up-to-date information about who's inside of your product or something like that, that is operational use case. That is an operational use case, not an analytical use case. It supports analytics, but the infrastructure there is operational. And I think that, we're probably over rotated on these issues of like, well, but you're storing that record twice. And it's like, if you think that's bad, wait until you learn what indexes in database systems are, right? They're really just different organizations of a lot of the same data, or materialized views, or any of these other things. They're just different copies of the data. So like, I think that what we should be thinking about is like, how do I meet the operational requirements, the cost requirements, or the cost optimizations, especially in this this like macroeconomic situation. I think that this architecturally has so many advantages, and it is not dissimilar from what it is what I think folks like Jay Krebs have talked about, like back in 2014, about the Kappa architecture and like all these other kinds of things. This is what it's getting at, is that you can actually drive multiple systems with the same data that are and allows those systems to be optimized for specific use cases and workloads.
And as you have been building Decodable, working with customers, helping them figure out how best to apply streaming to the problems that they're approaching, what are some of the most interesting or innovative or unexpected ways that you've seen your product used?
Frequently surprised with what people are doing with Decodable. I mean, we definitely see what I would call like bread and butter use cases, the filter, route, transform, aggregate, type of trigger, type of use cases that happen in the stream processing layer. I think that, one of the things that I have come to like really appreciate is this combination of, and I don't think this is these days all that unique, but I think at the time it sort of surprised me how simple it made things. This change data capture from an operational database system through the stream processing engine for munging of that data, and then pumping that back into other operational systems like caches and full text search. So like we worked on a use case with a company that takes in resume data, does a bunch of from MySQL, does a bunch of parsing and cleansing and transformation, and then indexes that data back into Elasticsearch to make resumes searchable by sort of different, basically different features of a candidate. And this process wound up being like zero code for them. It's like one SQL statement that does, very low latency, processing of this data and then sort of indexing back into the full text search systems. And I think if you think about, you extend that to things like caches, like Redis and those kinds of things, or Elasticache, like you actually start to see all of this opportunity to be able to create what amount to materialized views that are optimized for different workloads. Again, that's probably not super interesting these days, but like the kinds of applications that you can build and how fast you can build them, that's the thing that surprises me. We worked with a telco provider to take data out of this, I won't name it, this legacy ERP system with like hundreds of tables, be able to cook that data for fast lookup by things like customer ID and those kinds of things, so that it can be served out of basically specialized systems like caches and those kinds of things to support different kinds of applications. And like what would have been weeks of microservice development and like batch processing stuff winds up being, I don't know, a day or two of like a pretty gnarly SQL statement. But like that thing had 17 joins, correlated subqueries. Like it was just like, it was 220 lines to take this like legacy ERP, highly third normal form like database schema and cook this denormalized record for like fast lookup by customer ID and see like all the devices and like all these other kinds of things. So I mean, the speed and like time to market, I think, is the thing that is just like so interesting. But man, people get creative, I'll tell you that. Like they can do some stuff that, I mean, surprises me, the scale of it or the complexity of it, and like the fact that it kind of just works for people. Like that is, I would have killed for this stuff, 10 years ago. I really would have. But yeah, I mean, I think every week we probably see something new and interesting. It's exciting.
And in your work of building this system, building the product, working in this ecosystem, what are the most interesting or unexpected or challenging lessons that you've learned personally?
Oh, man, that's a good question. I think the amount of glue. So I think like the big thing is, especially as an engineer, like you look at these open source projects and they are like so sophisticated, so powerful. Debezium, Flink, Kafka, and everybody kind of goes like, yeah, our stack is like Debezium plus Kafka plus Flink, and the plus in that sentence, those two pluses are doing a lot of work in that sentence. And I think the thing that has surprised me is just how much time and effort we spend on the glue between these otherwise fantastic Lego bricks. And so, like, I'll be honest with you, here's probably the dirty secret about Decodable. Our differentiation is not like that we're 3 milliseconds faster than the other guy. Our differentiation is like all the glue in between those systems, the DevX, the deployment, the APIs, the orchestration, like all the observability. Oh my goodness, the observability alone around data pipelines in a streaming context. Data quality like looks different in a streaming context. It functions differently in a streaming context. So I think a lot of those kinds of things are just like much harder than I would have expected, or like, and maybe that's me being naive, but like the joke is like the old like draw the rest of the owl, kind of meme where you draw like two circles and then it's like draw the step two, draw the rest of the owl. I feel like that with like step one, deploy Kafka, Flink, and Debezium. Step two, like build the rest of the platform. I mean, like it's just the amount of time and effort is just daunting, especially like given that's like our full-time job here at Decodable. We spend all our time thinking about it. And I think if anything, it sort of shows that the need for these data platform teams inside of organizations, and the value that they provide, because the usability difference between here's 3 open source projects, go, good luck, and here's like the 3 open source projects with all of the tooling and the glue and the UX and like all this kind of stuff around the observability around it, is the difference between being successful with these platforms and not. It really, really is.
Absolutely. And so, with that context, for people who are considering Decodable or considering streaming, what are the cases where that's the wrong choice?
I think that I don't think that people should think about, excuse me, decodable or stream processing as I'm going to shut down my data warehouse, right? Like I'm going to like take my Airflow, DBT, and Snowflake and shoot it into the moon. Like that's just not what's going to happen. I think that we don't make that claim. I think that stream processing at its core is something that typically sits between two other systems, some source, some destination, and processes data to make it available in that system. I don't actually think that it's meant to be a serving system. So like we purposely decouple ourselves from like an Apache Pinot or an Imply or a Snowflake or a Databricks or an S3, a Redis, because we believe that you actually want those as two separate systems so that you can cook the data and then serve it in whatever most appropriate storage and query engine, that makes sense for a particular workload. So I don't think that people should be saying I'm going to replace Snowflake with Decodable or Databricks with Decodable or Postgres with Decodable. Like that is not necessarily how you should think about stream processing. So don't do that. I think that there are plenty of other cases where if you're thinking about how do I get data from Postgres through the outbox pattern to be available for microservices or like into HubSpot or something like that, or into Snowflake or S3, I think those are the places where decodable and stream processing fit.
And as you continue to build and iterate on and scale the Decodable platform, what are the things you have planned for the near to medium term, or any particular problem areas or projects you're excited to dig into?
Yeah, I think there's a lot we can do I mean, there's some stuff that's like evergreen. We'll always be adding new connectors. We'll always be improving like the SQL dialect. We'll always be sort of enriching the APIs to allow people more, expressive, capabilities. I think that there's some higher order functions that we can provide to people, like more sophisticated management of time and these kinds of things that codify some standard ways that people use this technology that basically makes it easier to build the jobs that run on top. Developer experience, I think, is always top of mind for us. It is not where it should be. There are certain things that are probably harder to do than I wish they were. Think operational flows, like making a backward incompatible schema change, for instance, is like a thing that sometimes needs to happen. You should avoid it at all costs, but like when it does happen, when it does need to happen, it's messier than it should be. Reprocessing of data, I think that's an area, and like bootstrapping net new things. Like I want to bring up a new Elasticsearch instance and I want to replay the last 12 months of data or something like that into it. I think those kinds of things, and then switch over to the stream. I think those things, you can do them today, but I think that they can be easier. So I think we're thinking about those kinds of things. And then I think there's probably a couple of things that we're working on that, we're probably not quite ready to talk about that we think will be really exciting for people, that are probably a little bit more nascent, maybe a little bit more moonshot. We'll figure out when the right time to sort of come out with those things.
Yeah, absolutely.
So interesting stuff.
Are there any other aspects of the work that you're doing at Decodable, the overall ecosystem of stream processing and when and how to apply it that we didn't discuss yet that you'd like to cover before we close out the show?
Honestly, I feel like, this is like probably one of the better like overviews that I really appreciate the questions. I think we probably hit like all the critical stuff. I would say that like a lot of people are still sort of struggling, I think, to understand where stream processing fits into the stack, into the platform, and which workloads should move to it. And we're, probably spending more and more time trying to think about how to help people understand that. I think, look, at its core, people can think about this as like low latency ETL that can power both analytical systems and microservices. I wouldn't stress much harder on it than that, but I think like, the operational to analytical and operational to operational data infrastructure is probably like the mental model that people should have for stream processing. But I think that might be one of the areas where we have some more work to do, and it's probably an evergreen topic, to talk about when we talk about this stuff. But otherwise, it's been a real pleasure, man. I appreciate it.
Absolutely. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh man, what is the biggest gap? I think the largest portion of the problem here is really one around developer experience, and I think my anecdotal evidence for that is that every team at every company at every Fortune 500 has like what I would call like the company specific data platform layer that glues this like set of things together in a way that makes sense for a particular company, for a particular team. And I don't think that there are yet developed standards the way I think we have on the application development, like the layers above. And I think that creates so much 6 of one, half a dozen of the other, just like it's different for the sake of being different development efforts that burn time and money. And like, I think that hurts people. I don't know the solution to that, but man, I wish we could come up with better patterns and practices for this stuff that encode it in a way that vendors can then sort of more tightly integrate with, so that there's less work for these data platform teams to do, because they really are doing like yeoman's work out there. It's rough.
Absolutely. Well, thank you very much for taking the time today to join me, share the work that you've been doing at Decodable, the changes that have happened since we last spoke. Definitely appreciate all of the time and energy that you and your team are putting into making stream processing a more tractable and approachable problem for people who don't want to have to invest their entire lives into it. So appreciate that, and I hope you enjoy the rest of your day.
Thank you so much for having me. It's always a pleasure.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.